Welcome to qnawire.
Okay, we've got some hydrocarbon with the formula C8H10. We know that hydrogenation with Lindlar catalyst, Lindlar's cat, used one equivalent of H2, and hydrogenation over platinum used 3 equivalents of H2. Great. What does this tell us? What is the information we get from these catalysts? Well, recall that Lindlar's catalyst will take an alkyne and reduce it to an alkene. Great. Now, also, realize that this is going to add 1 equivalent of H2. Actually, you know what? It'll be, it adds trans, so, sorry, it adds cis. So, let me draw this better. This would be up here. And this up here. Okay, either way. If you have an alkyne and you react it with Lindlar's catalyst, it will reduce it to an alkene and add a single equivalent of H2. So the fact that they used Lindlar's catalyst and it used a single equivalent of H2 tells me that there was a single triple bond. Okay, now let's look at this other catalyst. That's hydrogen on palladium. If we have an alkyne on and react it with hydrogen over palladium, we will actually go all the way to having not just the alkene, but the alkane, right? So if we have an alkyne and we react it with hydrogen over palladium, it's going to give us 2 equivalents of hydrogen. Furthermore, if we were to start with an alkene, be it cis or trans, doesn't really matter, and we react it with palladium over hydrogen, we would end up with the al. Let's do this so we show where these hydrogens are coming from. 2 of them are already there, but we will add 1 equivalent of H2. Right? Okay, so palladium on an alkyne will add 2 equivalents. Palladium on an alkene will add 1 equivalent, and Lindlar's on an alkyne will add 1 equivalent, and Lindlar's on an alkene will do nothing. Okay, so we reacted it once with Lindlar's and used 1 equivalent of H2. That tells me we have an alkyne. If we took that, so then we're taking that same molecule, it hasn't been reduced still, we're taking the starting material, so we know we have an alkyne in it, and we're reacting with palladium and hydrogen, and we've added 3 equivalents of H2. So we know that the alkyne we already had, if we reacted it with hydrogen over palladium, that's going to use 2 equivalents of H2. Then we're going to have, apparently there's one other something that used up the remaining 1 equivalent of H2. Well, it would make sense that it's an alkene, because that would only add 1 equivalent of H2. And if it was an alkene, it makes sense why when we reacted with Lindlar's catalyst, nothing happened, right? And we only converted our alkyne into an alkene. So maybe I could illustrate that better here. Let's say we have an alkyne and we have our alkene, and we react it with Lindlar's catalyst. Lindlar's, our product would be an alkene, and our other alkene would still be there. If we did an alkyne and an alkene with palladium, our alkyne would go to an alkane, and our alkene would go to an alkane, right? H2. And we didn't add any here, actually, right? That's one equivalent, three equivalents. Okay, so do any of these molecules have an alkyne and an alkene? And we've also got to consider the degree of unsaturation. So that's our final bit of evidence, is that it's C8H10. So we can find out how many double bonds and or rings this molecule has. So we need to use the degree of unsaturation formula, or double bond equivalence. Tells us the number of pi bonds plus the number of rings. Okay, and the formula goes carbon minus hydrogens divided by 2 minus halogens divided by 2 plus nitrogens divided by 2 plus 1. So in our case, that's 8 minus 10 over 2 minus 0 plus 1 equals 8 minus 5 plus 1 equals 3, 4. Right. So let's look at our proposed. We've got 2 pi bonds here, 1 pi bond here, and our degree of unsaturation is 4. So we know we have also we have 3 pi bonds and 1 ring. So it's a cyclic molecule with an alkyne and an alkene. That looks like this option here. That's our molecule.